Is it possible? Imagine a cosmic event of such magnitude that it obscures Earth even during daylight. That might transpire soon. Betelgeuse, a star in the Orion constellation, is acting strangely, which raises the possibility that it will explode into a supernova, illuminating our skies like never before. However, when will it occur? How will it, according to scientists, appear? And what secrets may this occurrence shed? Let's take a deep dive into the truth about Betelgeuse and how it might affect Earth and the entire solar system. Betelgeuse, located in Orion about 650 light-years away, is not just any star. Over 100,000 times brighter than our Sun, it is a red supergiant. But why is it important? Betelgeuse, on the other hand, is unique for its brightness and significance to human culture. It has been observed for centuries, guiding travelers and captivating stargazers with its reddish glow, and it is named after the Arabic word Yad al-Jawz, which means the hand of Orion. Imagine a massive star that could encompass our solar system. At 10 million years old, Betelgeuse is much younger than our Sun. However, due to its enormous size, it burns through its fuel more quickly, resulting in a shorter lifespan. Presently, approaching the finish of its life, Betelgeuse is near the very edge of a terrific finale, a cosmic explosion blast, delivering incomprehensible energy and splendor. Kepler's supernova, which was visible for weeks even in daylight, was the last such event to occur on Earth in 1604. Supernovae like Betelgeuse's are uncommon occasions, yet their leftovers offer significant bits of knowledge into the existence patterns of gigantic stars. Astronomers are excited by Betelgeuse's recent behavior. It experienced significant dimming from October 2019 to the beginning of 2023, attracting the attention of astronomers all over the world. By April 2023, it appeared to be back to normal, but in the months that followed, its brightness increased by 50%, which sparked speculation about its future. Could we be about to witness one of the most dramatic events in the universe? Betelgeuse's unpredictable behavior suggests that its breathtaking explosion may be closer than we think. As scientists continue to monitor Betelgeuse and unravel the mysteries of our cosmic neighborhood, keep an eye on this space. But why did the brightness suddenly change? Why did one of the most well-known stars in our night sky, Betelgeuse, suddenly throw a cosmic curveball? Stars are not simply glimmering spots in our night sky. They are dynamic substances with life cycles, action, and secrets of their own. Similar to the rhythms of the seasons on Earth, periodic brightness variations can be predicted for many celestial bodies. In its heavenly lifetime, Betelgeuse is timed in a genuinely predictable 400-day iridescence cycle. However, with the extraordinary darkening, it appeared to oppose its known nature, testing how we might interpret the divine marvels above. Presently, you may be pondering, would we say we are near the very edge of a heavenly disclosure? A convincing theory has emerged, despite the fact that the precise causes of Betelgeuse's irregularities are still the subject of investigation. A tantalizing scenario is suggested by this theory, which centers on stellar activity and mass ejection. Imagine Betelgeuse as a massive celestial volcano that suddenly bursts into flames and releases a huge amount of its contents into space. Before, perceptions from the Hubble Space Telescope revealed that Betelgeuse has recently launched out a gigantic measure of its surface material into the universe. This enormous ejection had a mass 400 billion times greater than that typically released by similar solar events, or several times that of our Moon. Such occasions can prompt the development of a thick residue cloud around the star, influencing its evident brilliance and making it briefly harder to notice. Then, at that point, when this residue started to scatter or was driven away by the power of the star's radiation pressure, the shroud lifted. Its subsequent return to normal brightness levels may be explained by this. In any case, these recent events point to a star who isn't done surprising people. Betelgeuse may be approaching a supernova event, according to some speculation. A supernova is a catastrophic explosion, an incredible burst of energy that can briefly outshine a galaxy. When the core of a star undergoes a sudden change, this phenomenon occurs. But what causes the demise of a massive star like Betelgeuse? Stars like Betelgeuse, which burn hydrogen in their cores to begin their journey, are born from the gravitational collapse of gas within molecular clouds. The foundation of a star's life is this initial phase, also known as the main sequence stage, which lasts for millions of years. In any case, as stars run short on hydrogen, they develop, embracing new energy sources. On account of Betelgeuse, as the hydrogen drains, it starts to consume helium, prompting the development of carbon and oxygen. The star's growth into a red giant marks this transition from the main sequence phase to the helium-burning phase. The star expands further over time as its helium reserves decrease, transitioning into additional burning phases marked by the fusion of increasingly heavier elements. Due to the enormous forces exerted by gravity, these transitions accelerate with increasing star size. The climax occurs when iron begins to form at the core. Iron does not release energy when fused, unlike lighter elements. As a result, the energy produced cannot withstand the star's own crushing gravity. The star inflatables in size and makes a collapse, trailed by a gigantic bounce-back impact, bringing about the dangerous power of a cosmic explosion. So, Betelgeuse, is it waiting its turn or is it about to explode? Late examination by Japan's Tohoku College recommends that the star may be in its carbon-consuming stage at this moment. After the core's carbon reserves run out, according to lead researcher Hideyuki Seo, it may collapse in a few decades. However, not all scientists concur. Contrasting research from the Konkoly Observatory in Hungary suggests that Betelgeuse is still in the early stage of helium burning. Betelgeuse is predicted to become the next supernova in the Milky Way, which is the one thing that scientists agree on regardless of these debates. However, it is still a cosmic guessing game to determine when this event will occur, with bets ranging from a few decades to 100,000 years. One fact remains unquestioned in the midst of these scientific speculations and debates regarding Betelgeuse's fate: the very nature of our observation. We often overlook a subtle paradox when we look up at the starry sky. This oddity is established in the actual idea of time and light in our huge universe. Stars and divine bodies are far off to the point that their light requires some investment to arrive at our eyes. For instance, even though it travels at an astonishing 186,282 miles per second, there are still limitations. As a result, the light from distant stars and galaxies takes a long time to travel through the vastness of space before reaching us. When you look at Betelgeuse, you're actually watching a show from 650 years ago. To put that into perspective, the Renaissance was just beginning, and explorers like Marco Polo were making their mark on history, at the same time that this very light began its journey toward Earth. Each perception we make of Betelgeuse resembles glancing through a grandiose time case, giving us bits of knowledge into its far-off past. Furthermore, if, for the well-being of contention, Betelgeuse had previously detonated in an imminent cosmic explosion, we'd stay neglectful for an additional 650 years. Thus, while we examine and foresee its looming cosmic explosion, someplace out in the huge universe, this fantastic situation could have proactively unfurled. It just needs to travel through space and time before it reaches our eager telescopes. The new disclosures around Betelgeuse have prompted intense conversations in the cosmic local area, with correlations being attracted to one more electrifying revelation from recently, SN 2023X. Many people were reminded of the fascinating dynamics and unpredictable nature of the universe by this recently observed supernova, which occurred in a galaxy adjacent to the Milky Way. In its own right, this SN 2023X was distinctive. At a distance of several million light-years, it displayed an intense display of brilliance that briefly outshone the galaxy it was hosting. However, its striking resemblance to what many predict will happen to Betelgeuse made it particularly intriguing for both scientists and casual observers. A tantalizing glimpse into the processes that these massive stars go through as they approach the end of their life cycles was provided by the spectrum, intensity, and aftermath of the explosion. For some, SN 2023X filled in as a review. The sequence of events may resemble that of SN 2023X if and when Betelgeuse meets its explosive fate. Likewise, the association between these two divine occasions highlights a more extensive subject about the interconnectedness of our universe. Whether it's an adjoining star like Betelgeuse or a far-off cosmic explosion, for example SN 2023X, these grandiose peculiarities help us to remember the dynamic and developing nature of room. The domain of room investigation is brimming with unknown regions and strange problems, And no place is this more obvious than in how we might interpret red supergiants like Betelgeuse. These celestial giants conceal some of the deepest secrets of the universe, which are as mysterious as they are brilliant. Although it has been charted, red supergiants' life cycles are fundamentally ambiguous. While we realize that these stars advance from the primary grouping stage to their excellent supergiant height, the delicate processes are less perceived. These phases, which may involve violent changes in the core of the star,